thank you to the Iowa Swine Day committee for asking me to come and give a presentation on some of the research that we've been doing, and particularly just some of the work that we've been doing looking at dietary feed technologies or dietary feed additives and how they work within a pig under different types of stress. And that's the topic that I'll discuss today. Before I get into that topic, I just want to give a quick update. A lot of people have been emailing us with regard to what's going on with our growth restriction or holding diet research. We have finished the majority of the carcass evaluations on some projects that we've been doing, and in the next 10 to 14 days through the Iowa Pork Industry Center, we'll record an overview of that research and present that in a video uplink that people can look at. And, Jason and Stacey will send out an email when that's ready. So we'll have an update very shortly for everyone. We are still continuing to work heavily in that research area. A quick overview of what the topics I'm going to cover in about the next 45 minutes is really I'm going to give a definition and the context of stress in a growing pig. We'll talk about some of the physiologies of the pig that may be targeted by different stresses. Also, importantly, what constitutes a successful outcome when we're using different dietary strategies to mitigate stress. And then I'll touch on some efficacy of dietary feed technologies in nursery pigs. And then I'll finish up with some nutrition physiology by disease interaction work that we've been doing and some of the success stories I believe that we've reported so far. So really, when people say, oh, I want to look at stress in a pig, what are they actually looking at? And I think here the topic needs to be contextualized. In other words, what is the context of what we're looking at? Are we looking at a weaning transition stress? Are we looking at disease pressure? And even within disease, are we talking clinical versus subclinical? Because we can have very different outcomes when we're talking about nutrition if we're trying to mitigate a clinical disease outcome versus a subclinical disease outcome. And then based off the years of research that I've conducted, it's very hard for us to actually see a lot of nutritional strategies really kind of attenuate clinical disease at peak infection. And that's because we're trying to use nutrition and we're not using drugs or pharmaceuticals to actually mitigate some of the clinical pathogens in question. And so really we're studying nutrition under the context of a sledgehammer type stress versus a tack hammer. And so I think it's important to understand the context of when different nutritional strategies are actually working. Is it under clinical or subclinical disease? Is it under weaning stress? Is it under climate stress? It could include heat stress or ventilation. Is it to do with mycotoxin burdens? And all of these are going to be very different. Just like the previous speakers stated, that it's going to be horses for courses, or it's going to be kind of flow-specific nutritional strategies, and not one nutritional program is going to fit everyone. It's going to be it also depend on genetics and so forth. Also, when we define stress, we're really talking about a dysbiosis, or actually a attenuation of homeostatic properties within different systems or tissues. But the stress can actually be localized or it can be systemic. So if we talk about porcine epidemic diarrhea virus, it's very localized to the small intestine of a pig. It disrupts the enterocytes or absorptive cells, compared to, say, PRRS, where PRRS is going to be more systemic, and then also more targeted to alveoli macrophages. We also can think of inflammation and oxidative stress. In the world of nutrition, we talk a lot about inflammation, or the ability of different nutritional products to mitigate inflammation or pro-inflammatory responses, or mitigate oxidative stress. However, I would argue we don't really know what baseline is, so it's very hard to say if it's actually truly going to be beneficial, and to what degree is an improvement in inflammation or oxidative stress actually beneficial to the pig. And then also, what physiologies are we targeting? Are we actually trying to improve digestibility, appetite regulation, nutrient absorption, or lean accretion and protein turnover? All these are going to be targeted by different pathogens and different stresses. Some stresses may target all of these, and other stresses may be specific to appetite, or may just be specific to digestion and nutrient absorption. And so if we closely look at weaning stress, and the previous speakers kind of set this up quite nicely, but really this is, let me get a laser point here, but really this is a weaning stress. If we talk about 19 to 21 days a post-wean pig, we see that if under natural wean circumstances where the piglet could wean itself, gut barrier function integrity is going to be optimal. However, when we early wean, we can have compromised gut barrier function and development, and therefore we can have suppression of the immune system within the pig. We can have increased mast cell activity and number. That's work from Dr. Mosier's lab at Michigan State. We could also see changes in intestinal integrity and function that were really first reported in France by Dr. Lally's lab. And also we can see that there's going to be a hyperenteric nervous system reaction to different pathogens, diet changes, and also environmental stress. And all these are going to actually compromise the pig. And so what we can do, we can use feed-grade antibiotics, or we used to be able to use feed-grade antibiotics, and we can use functional feed additives to actually mitigate this. So we can actually improve a pig's digestive capacity and barrier function to actually have more normal gut development. So we can improve maturation, improve the ability of the pig at weaning to actually transition from a milk-based diet to a solid feed-based diet. And the previous speakers talked about gruel feeding and palatability, etc. And these are all different ways that we can actually improve this. However, with increasing regulatory pressures and with the introduction of the Veterinary Feed Directive in 2017, we're actually losing or have lost a lot of technologies that we can use to actually improve weaning transition. And particularly in Europe right now, with the ban on zinc oxide or therapeutic levels of zinc, also with the banning of subtherapeutic growth-promoting antibiotics, we're losing technologies to actually help these pigs transition. And then there's an opportunity for different feed additives to come in and actually help mitigate these differences. But one thing when we're talking about nursery pig performance, we got to remember we got to also target the bottom 80th percentile of the pigs that are transitioning. So this is a little pilot study that we've been conducting for the last couple of years. But really, we had 120 early wean pigs that we put on test over a few nursery flows. These are individually penned pigs. They all start off with an average body weight of about 5 kilograms. And then at the end of that, we just broke it down to the 20th percentile and 80th percentile pigs and what was going on with growth rates and feed intake. And so we have our high growth rate pigs in this population of PIC pigs that we can over a 5-week period, we can actually get about a 20 kilogram body weight in these pigs. Compared to our low growth rate pigs, they're just over half of that. They're only about 12 kilograms. And a lot of that seems to be associated with feed intake. And so driving feed intake early on, especially in the first week, is actually going to be critical in actually getting these pigs to grow. So there's opportunity to use nutrition to get these red pigs or these bottom pigs up to be closer to our high growth rate pigs within the nursery. And so, but we need to spend more time focusing on the bottom end of the pigs. And these necessarily aren't the fallback pigs or runt pigs. These are pigs that just don't start well. And so we need to focus on this. The other thing when it comes to stress, we can talk about disease. And disease, as I said, can be broken into 2 categories. And so really we can talk about clinical disease, and then clinical disease presentation is going to be a combination of susceptibility of the host, which can be derived through the differences in immunity, nutrition, genetics, and also the environment, the facilities, the management, and also what pathogens are present, and also what vaccines are there. And also, it's the dose and the virulence of the pathogen is going to lead to the pathogen being expressed and then leads to the exposure or expression of the disease phenotype. But we can also have a lot of cases in which we see subclinical disease. And this is where it's harder to see. And then this is where I think there's a greater opportunity for nutrition to actually come in and actually help pigs that are more subclinical with regard to disease presentation. But when we talk about disease and stress in general, whether it's weaning stress, pathogenic disease, environmental stress, etc., we're really talking about the ability of a pig to metabolically prioritize resources in different manners. And this can be ranked, and this is work that was done in the 1950s by Hammond and others. But really, when we think about the pig and its resources, the feed that comes in, the nutrients and the energy that comes in, are going to be prioritized towards brain and fetal development first. Or if we're talking about a growing pig, we're talking more about the brain and the immune function, then visceral organs. And then after that, the priority then goes to muscle and adipose tissue, and we'll call it the growth aspects of the pig. And as a stress changes, there's more of a priority towards maintaining these brain function, immune function, etc., and visceral organs than there is over lean tissue and adipose tissue. And this is going to be driven by cytokines and hormone-driven responses. So a change in pro-inflammatory cytokines is going to drive more than metabolic priority. And this is going to be tissue-specific or system-specific to the brain and immune system versus what's going on with muscle and adipose tissue. And so this is the biology that we're up against when we're trying to feed sick pigs. And so this is a cartoon that I use in class for some of my students. But really, how do pigs respond to disease or stress? But really, the first thing is pigs will go off feed, like the previous speaker said. There's a reduction in nutrient intake and energy intake. It's like when we get sick, one of the first signs that we're kind of sick is really we just don't have appetite anymore. And therefore, depending on the disease state, we can actually decrease digestibility and then nutrient absorption. And again, it's going to be context of what the stressor is or what the disease is. Then that also leads to reduction of energy and amino acid uptake into the body to support lean tissue accretion. But then if disease and stress is severe enough, it leads to a reduction in amino acid supply. Therefore, it's going to actually attenuate protein synthesis. In particular, it's actually going to limit mammalian target of rapamycin or protein translation initiation. And this here will actually lead to a decrease in lean accretion in the pig. And that can also be accompanied by changes in reactive oxygen species, localized changes in inflammation and muscle proteolysis. That all of this leads to, if it's severe enough, it leads to the liberation of amino acids from muscle. And these can go to the liver to really support immune cell components, glycogenolysis, gluconeogenesis, puts glucose into circulation to help energy and amino acid needs for the febrile response or the fever response and the immune response. So really under a prolonged duration, this is when we get pigs going from A pigs to C pigs, if the C pigs are actually mobilizing more of their internal resources, and that's actually been exacerbated by the fact that they've just got reductions in nutrient intake. And so what I thought I'd do before we get into some of the nuts and bolts of different feed additives and stress models is what constitutes a successful outcome. And this is my personal opinion of what I think a successful outcome would be if we're using nutrition to actually improve growth performance of a pig. And so we could break it into three key areas. And these may not necessarily be dependent on each other. But one thing that to me would classify as success is that we can reduce clinical and subclinical disease presentation. So we could decrease pathogen disease susceptibility, in other words, the ability of a pig to become sick and express a disease phenotype from the pathogen. If the pig happens to become sick, we can actually decrease the pathogen shedding. Therefore, it's actually more beneficial to the barn or the community of pigs around that animal. So decrease shedding profiles. And then the other thing that it could do, we could improve the resolution or the duration of shedding or the duration of disease presentation in those pigs or pathogen presentation in those pigs. Either of these three outcomes you could classify as a success from a population level. And then the other two don't necessarily go hand in hand, and I'll show some of this data later on. But really, the other way to constitute success in my mind with different stresses is there an improvement in survivability? So is the number of pigs that actually survive due to that stress, whatever that may be, could be pathogen, could be environmental, could be weaning, etc. Is that improved? So we can have an improvement in survivability, but yet we may not have any differences in pig performance. And then the other category, which is probably a little bit more cleaner for what I do, is actually to assess improvement in peak performance. And then with that, I would put an emphasis on improved lean accretion or growth rates. And particularly, it's not just necessarily growth, but lean accretion, I should say. Because we can have an improvement in growth of a pig, but some of that may be at the expense of dressing percentage, or in the sense that we're actually increasing more visceral growth in response to a disease or stressor rather than lean tissue. And then that can also be broken down into some short-term benefits, long-term benefits, and also there's some compensatory benefits that may be seen in the sense of a post-stress growth response or performance response. The other thing associated with growth performance could also be feed intake. So really, I would classify successful outcomes of using a nutritional program to mitigate a stressor would be either reducing clinical or subclinical disease presentation or stress presentation, improve survivability, and improve peak performance, whether it's growth or feed intake, but particularly on the growth side. And so if we fall into the trap is that a lot of times, and I'm guilty of this as much as anyone, is that we look at the mode of action or the mechanisms to try and understand how different nutritional ingredients or nutritionally active ingredients are actually improving a outcome of a pig. However, I'm going to stress, and I'm going to hammer this point home every time I get, is that looking at the mechanism or a mode of action of how a nutrient or a novel feed ingredient improves an outcome is absolutely pointless unless the disease or stress phenotypes are presented with that work. And I'll give two examples here. And I'm not going to cite any papers here, but I can bring up many. Some examples would be people that just look at pro-inflammatory cytokines, and then they might do a pathogenic E. coli challenge in some nursery pigs. They report no differences in shedding or survivability of the pigs that are in question compared to the control healthy pigs, or they show no benefits in growth rates or performance parameters over the challenge period, which might be anywhere from a 3-day to 14-day period. Yet they report there's an improvement in pro-inflammatory cytokines. In other words, there's an attenuated inflammatory response in these pigs. Yet none of that has actually transitioned to actually pathogen shedding, performance, or survivability. So therefore, is it an actual beneficial outcome? And so if it doesn't meet the three criteria, I would argue maybe it's not so much. The other thing is that these studies also need to present the phenotype data with some of this stuff. And this particularly also goes for the metagenomics work. There's a lot of studies in the literature that have been reported that they show that feeding a DFM or feeding something to a pig changes the gut microbial populations compared to a control pig, but yet there is no performance data presented at all or even at any time within that study. So therefore, they might see a couple of different genres or families of bacteria change in response to their treatment intervention, but however, we have no idea what that actually means because there's no performance data or disease data or stress phenotype data presented alongside that. And so it really is hard to say what the actual benefit was. So what I'm saying is that if we're trying to look at nutritional interventions or nutritional strategies to improve performance of a stress outcome, we need to make sure we present the mechanistic data needs to have the phenotype data to go with it. And so if we talk about different dietary technologies, a lot of these aren't new. We can really talk about direct-fed microbials or DFMs. If we're on the human side, they're called probiotics. We can talk about prebiotics, oligosaccharides, resistant starch, and fibers. There's organic acids. There's essential oils, botanicals, plant extracts. There's yeast. There's live and dead yeast. If the live yeast would fall into the probiotic or direct-fed microbial category. There's minerals, zinc and copper in particular, lysozyme, fatty acids. We could talk about functional fatty acids, in particular if we're talking about omega-3 fatty acids, particularly if we're talking about linolenic acid, DHA and EPA from fish oil, and then also omega-6 fatty acids. And then more recently, there's been a lot of buzz about medium-chain fatty acids and the ability of medium-chain fatty acids to actually improve peak performance and also antiviral, antimicrobial properties. And all of these are different dietary categories. And I'll quickly just go through 2 or 3 of them and then just talk generically about some of them. And so we talk about direct-fed microbials. Most common category are going to be bacillus, spore-forming. There could be lactic acid producing bacteria, lactobacillus, bifidobacterium, enterococcus, etc. And there's also yeast. These will be the 3 most common categories. Most of the time that these direct-fed microbials are only fed either as a single or in duplicate or in twos. In other words, there's two species or families fed together or just one. And then the mode of action of how they actually work in pigs is actually going to be potentially to inhibit pathogen adhesion to the intestinal epithelium. They can produce antimicrobial substances. In other words, they can increase short-chain fatty acid production through enhancing fermentation in the hind gut. That can be beneficial. And then they can also modulate the host immune response. If we talk about organic acids, these are really just weak acids or organic acids in their salts. They can reduce the pH of the water and also in the feed. And we're talking about the combination or single use of a citric acid, formic acid, fumaric acid, and lactic acid that are commonly used. And it's really the change in pH and forming a micro pH environment in the intestinal epithelium that has antimicrobial properties that actually inhibits actual adhesion and uptake of pathogenic bacteria. They can also lower stomach pH and therefore improve protein digestion, so help with just the acid hydrolysis of proteins. And then other things that these short-chain fatty acids or organic acids can actually do, they can enhance energy. They can be an energy source and utilization, particularly in the hind gut, and particularly if we're talking about butyric acid. Zinc and copper are commonly used, have been commonly used at therapeutic levels, and then particularly in North America at the moment, we use zinc and copper at therapeutic levels to help weaning transition. However, the use of zinc and copper at therapeutic levels has been eliminated in the European Union. And when we're talking about zinc and copper, or at least with zinc, I'll just focus on zinc, we're talking about feeding pharmacological levels of up to 3,000 parts per million. So anything above really 100 to 120 parts per million, we're going to call that therapeutic levels. And these modes of action is they can reduce or prevent post-weaning diarrhea. They can increase microbial peptides in the small intestine. They can reduce gram-negative bacterial populations. And then they've really been shown to drive feed intake and also improve growth rates in nursery pigs. However, we've got to be careful. Prolonged feeding of therapeutic levels of zinc, and particularly there's people out here at least in North America, that will feed 3,000 to 4,000, 5,000 parts per million for over 4 weeks, can cause toxicity and reduce actual nursery pig performance. In particular, they're actually going to hurt the bottom end of your nursery, and it will lead to an increase in pancreatic lesions, and therefore over time, the zinc can actually cause the toxicity in the pancreas and therefore have an impact on pancreatic function. Also, high levels of zinc, therapeutic levels of zinc for a continuous period of time, can antagonize copper and selenium and other mineral concentrations and availability within the pig. So in other words, we've got to have a word of caution of feeding high levels of zinc and copper. And the other thing that when we talk about nutrition, and this is some work that we've been doing for the last few years, is that we're talking about using nutritional alternatives to subtherapeutic antibiotics. And this is something that I say to lots of people, is that when we're trying to look at alternatives to antibiotics, or we say that we've got an alternative to antibiotics with regard to a functional nutritional product, what are we actually trying to replace, or what are we actually trying to do with this functional product? And so if we're talking about an antibiotic alternative, it's going to fall into either therapeutic levels or claims, which we're not allowed to do. But really, we're talking about trying to replace the use of subtherapeutic growth-promoting antibiotics, or at least growth-promoting antibiotics, if we're talking about Mecadox, etc. So really, what are we trying to replace? And here, we're trying to replace about 4 kilograms worth of gain over a 5-week period using subtherapeutic chlorotetracycline, which is now off-label. We're not allowed to do that. So we're trying to find nutritional strategies and technologies to actually regain growth of pigs. And so we want to be able to increase growth, restrict or at least growth rates and feed intake above a non-antibiotic fed pig. And that's what we want our nutritional products to do. So if we're looking for alternatives to antibiotics, if we're trying to call it an alternative to growth promoting antibiotics, we've got to make sure that what we're feeding is actually improving growth rates of the pig. And so based off this, Wes Schwer, a former PhD student of mine, did a literature review for the National Pork Board about 2 years ago now. And then really we want to know the efficacy of different novel feedstuffs or feed technologies in nursery pigs, and could they actually improve growth rates in the pig? And so I'll give a quick synopsis of this, but actually I'm going to focus more on the actual stress aspect of this review that Wes did in the next couple of slides. But Dr. Schwer, he reviewed papers from 1990 to mid-2018, and then wanted to know what percentage of these papers showed improvements with growth performance, with feed intake, improved survivability, and feed efficiency in these pigs. And so what Wes did, he actually divided this up into about seven different categories. So we looked at direct-fed microbials or probiotics, looked at yeast, prebiotics, oligosaccharides, starch fibers, organic acids, botanicals, lysozyme, and zinc and copper. And then we looked at the percentage of papers that reported significant improvements in, and that would be indicative by a plus, or a negative would be a decrease in average daily gain, average daily feed intake, feed efficiency or gain to feed, and pig survivability. So an improvement in pig survivability is just reduced mortality. And here's the number of trials that were evaluated, and this number can actually probably be increased by 10 to 15% since we actually published this work. And then what we saw is that direct-fed microbials about 40% of the time led to an improvement in average daily gain. We saw the use of yeast, the yeast products, that's live or dead yeast products. Average daily gain was improved about 24% of the time that in the trials that we evaluated. Prebiotics, oligosaccharides, starches, it's probably about a 10 to 15% if we want to clump all these together, led to of the time that we had improvement in average daily gain. And botanicals, so we're talking about oregano, etc., and other botanical products. You could put seaweed in here. About 23% of the studies reported an improvement in average daily gain over the nursery period for this. And zinc and copper about 40% of the time. So zinc and copper at therapeutic levels and direct-fed microbials were some of the better categories. And then when we look at reduced mortality or improved survivability, we see organic acids did a good job. About 6.6% of the studies that reported an improvement in survivability, about 5% for direct-fed microbials over the period that we listed. And I'll say that if you want to know more about this lit review, you can go to the National Pork Board website, or you can look up this paper here that we've published on this. But what about under stress situations? And so how many of these studies, and we evaluated about 2,000 studies, how many of the studies actually reported improvements in performance or survivability during stress? And of the papers or trials that met our criteria, only 9% of them were actually conducted under a stress environment. And the stress environment could have been either under heat stress or temperature changes, ventilation changes, could be under unsanitary environmental challenge models, could be under mycotoxins. But primarily, most of them were actually, a lot of them were pathogen-related, in particular bacteria-related. So these 174 challenge studies that we evaluated, a lot of them were E. coli based, where they looked at K12, K88, F18 E. coli. They looked at some salmonella and also used endotoxin or lipopolysaccharide challenge models to evaluate whether a nutritional intervention was going to be beneficial or not. I will say there was limited number of studies that use viruses such as PRRS, influenza, PED, or rotavirus. And I think this is a big area where a lot of these products that were evaluated in this review may be more beneficial under rotavirus or PED situations. And I know since we did this review that Pipestone and Kansas State have produced some data, published data that is more viral related to do with some of these products. So how did these products go? Really, if we look at average daily gain, this is percentage outcomes here. The yellow is actually a positive response. A red is negative response. Grey is no response at all, and blue is not reported. Overall, if we compare non-challenge, we had about 1,850 trials were evaluated compared to the 174, but about 30% of the time these studies reported an improvement in average daily gain under non-challenge, but then it was down to 25% during a stress challenge environment. And again, with feed intake was improvements where we're seeing about 14% of the time. In non-challenge and the defined challenge stress situations, it was 12% of the time there was improvement in feed intake. But what's interesting is that really if we look at mortality, a lot of the times mortality was not reported, but under challenge conditions, there was a 5.2% of the studies actually reported improvements in survivability or a decrease in mortality compared to only 2% under non-challenge. And so, again, if we're looking at survivability as an outcome, there are some positives with different nutritional strategies compared to a control diet. So what about the different efficacies of direct-fed microbials, probiotics, prebiotics, etc.? If we look just within the challenge categories. And so of the studies that looked at direct-fed microbials here in this first column, the yellow bar here is the percentage of studies that of the 43 studies that were done under challenge conditions. 35% of those studies showed an improvement in average daily gain with regard to actual use of a direct-fed microbial. Only 2.3% of the studies reported improvement in survivability. Compared to using zinc or copper, there's 15% of the studies showed improvement in survivability here, and also organic acid. So if we're talking about a survivability outcome, organic acid and zinc and copper, followed by yeast, showed the best efficacy with regard to improving challenges, or improving survivability, I should say. If we look at just based on performance using average daily gain as an outcome, lysozyme, zinc and copper at therapeutic concentrations were very efficacious, very good at improving average daily gain, and then 33% of the organic acids and probiotics or direct-fed microbials showed under stress situations, they improved average daily gain. But the problem is that if you look here, the number of trials that were used in this study that met our criteria is very low. And so if we want to use nutritional strategies, we need to have more studies that are published that are going to define the different stresses and different stress outcomes in the face of different nutritional strategies, so we can improve this number compared to our non-challenge number. And then that will be able to help to say what nutritional programs will improve stress outcomes and performance of growing pigs. So if we change topics a little bit to look at what is the impact of pathogens in disease challenges and altering nutritional partitioning performance in growing pigs, a lot of the work we've done is just focused on these pathogens here or disease models, and then we've done this work in nursery through to finishing pigs. But really, I'm just going to fly through some of this stuff using a subclinical Lawsonia Mycoplasma hyamoniae challenge. Over a 42-day period, we see, compared to the control non-challenge pigs, that we see the average daily gain, average daily feed intake, and feed efficiency is going to be reduced by about 17 to 10% in these pigs if we compare the control versus challenge pigs. We also see that protein or lean accretion is going to be decreased about the same as what average daily gain is decreased. So it's going to be about that 17% reduction in body lean accretion when we examine these. We see something similar with just a pure Lawsonia challenge over about 19 days when we just infect pigs with Lawsonia. there's about a 40% reduction during peak infection of Lawsonia, in average daily gain, 25% in feed intake, and about a 25% reduction in feed efficiency in these pigs over a peak infection period. Recent work has shown the zinc amino acid complexes, and also previous work has shown the distillers grains, corn distillers grains, may be also beneficial in minimizing peak infection and also improving growth performance in Lawsonia. But there needs to be more studies looking at Lawsonia and how Lawsonia is impacted by diet. If we look at porcine epidemic diarrhea virus in nursery pigs, this is some work that was done by Dr. Curry back in 2017. We can really see within 5 days, this pig here, these are nursery pigs of about 10 kilograms in body weight that were infected with porcine epidemic diarrhea. This pig has pretty much lost a lot of its digestive capacity in its small intestine. You see the thin-walled, watery intestines, a lot of epithelial area has actually been lost compared to the control pigs. But these pigs also recover relatively fast post-weaning. And this can have an impact on overall peak performance if we're talking about a 42-day challenge period. So if we start off with about 10 kilogram pigs over 42 days, there's about a 6 kilogram end body weight difference that translates to about a 16% reduction in average daily gain in nursery pigs and about a 30% reduction in feed intake. And then again, we see average daily gain is similar to what we see with reductions in lean accretion of these pigs. And so if we're talking about, hold on a second. Yeah. So if we're talking more about nutrition and disease, I'm going to present 2 different diseases or pathogens and how nutrition has been shown to be beneficial with these 2 pathogens and disease states. One is going to be to do with swine dysentery using Brachyspira and Dietary, and the other one will be with PRRS. And so what we've done here, this is this work that we completed late last year and earlier this year. That's unpublished work by Emma Helm, a PhD student of mine, and in collaboration with Dr. Eric Burrow at the Iowa State Veterinary Diagnostic Lab. We're interested in seeing what is the longitudinal impact of swine dysentery on pig performance, and also what does it do to digestibility in these pigs when we feed pigs different types of prebiotics. In other words, we're talking soluble fiber, resistant starch versus insoluble fiber. And so, for instance, if we're just talking about peak infection as around 10 to 16 days post-infection, swine dysentery, actually, if we compare our negative control, these were pigs that were non-challenged compared to our positive control pigs that were challenged. We see that swine dysentery actually reduces growth rates and feed intake by about 90%. In other words, during peak infection, we have a big impact on pig growth and feed intake. However, when we change the diet of pigs that are prior to infection with swine dysentery, we feed them a diet high in soluble fiber. In other words, we just use beet pulp and resistant potato starch. We can actually improve average daily gains on these pigs, and we can improve also feed intake and feed efficiency compared to our positive control pigs. But we never get them back close to the negative control during a peak infection. We also see that using that swine dysentery actually reduces total tract nitrogen digestibility by about 75%. And then really the impact here is due to the fact that this disease causes a lot of mucosal secretion, and therefore the pig is actually secreting a lot of endogenous proteins into the lumen, and therefore that's actually inhibiting total tract digestibility. But feeding a prebiotic, in other words, feeding soluble fiber and resistant starch, we're actually improving nitrogen digestibility and also maintaining energy digestibility in these pigs. And so a lot of work has been done with swine dysentery, not so much in North America, but in Europe and also in Australasia. And then they've shown that diet can influence swine dysentery disease expression. And then we can have, using diet, people have shown to reduce disease indices when diet is highly digestible. In other words, if they use rice starch, or they use a diet high in inulin, it's been shown to mitigate swine dysentery expression in younger pigs during a pig infection. And then more recently, Dr. Wilberts and Dr. Burrow at Iowa State Vet School in VDL lab, they have shown that pigs that are fed high amounts of corn distillers grains actually are more susceptible to swine dysentery compared to pigs fed more of a corn soy-based diet. So based on this body of work, what we want to show is how does dietary fiber and resistant starch, so we'll call it high fermentable dietary fiber and resistant starch, mitigate swine dysentery and improve longitudinal growth performance in pigs that are infected with swine dysentery. And so with this study here, we actually used diets, 3 different diets. We had a control diet that was low in soluble fiber and resistant, or had no resistant potato starch in it, and it was just a high distillers diet, which had 20% distillers grains. Then we had an intermediate diet, which had 10% soluble fiber resistant starch, and then actual 10% distillers grains, and then a diet that had no distillers grains, but then had 20% resistant starch and beet pulp in that diet. And so these are the diets here. We had about 20% corn distillers. We had either one with 10% or none. And then we split beet pulp and resistant potato starch 50-50, or made up 10% and 10% in the high soluble fiber diets. And so what we want to know is, does dietary fiber, and to what extent does dietary fiber actually mitigate disease of swine dysentery in the pig? And so we started off with a 40-kilogram pig in this case, and we grew them out for 42 days, and we infected all these pigs. Were infected, so we infected these pigs after 14 days of the challenge, and then, or after 14 days, we infected these pigs, and then we had an end body weight of around 73 to 95 kilograms in these pigs. Now, really, what I want to highlight here is that by changing the fiber of the pig diet, we had a significant improvement in pigs that were all infected with actual swine dysentery. So we actually improved average daily gain by about 130 to 160%. So we go from about 800 grams a day to a kilogram a day to 1.25 kilograms a day over the test period with these pigs. All pigs actually at some point during the challenge period tested positive for BHIO, but only as we increased the amount of soluble fiber or beet pulp in the diet and resistant potato starch, the number of pigs that were clinical actually decreased. And so this data really highlights that using actual dietary fiber, and particularly fermentable fiber, can actually improve the disease outcome and the performance of a pig. And this would be particularly important for antibiotic-free or no antibiotic ever type diets. Similar studies have been conducted with E. coli and shown similar results. When we improve the solubility of the diet, you can actually improve the outcome of the pig. But this chart here, or this table, this figure here really just highlights it more importantly. So we inoculated the pigs at day 0 after 14 days on feed. It took about 7 days for the pigs to actually develop clinical signs of dysentery. We had a reduction in average daily gain or body weights over this period of time. And then these pigs never caught up over the 42-day period, even though that most of them were resolved by this point here. This is our high distillers grain, no soluble fiber diet. And as we increment our resistant potato starch and beet pulp in the diet, we get a graded improvement in performance. But really, the pigs that had no distillers grains and an improvement in and high amounts of soluble fiber and resistant potato starch at 10% each, respectively, in their diet, we can see that their growth performance didn't really skip a beat over the 42-day test period. So this is showing that a prebiotic is actually being very beneficial at mitigating this enteric disease over time. And this could be very applicable to an ABF environment. If we switch gears in the final part of the presentation, we just talk more about PRRS, and then how PRRS can attenuate lifetime performance of the pig. Work that we've conducted back in 2017 actually showed that We can PRRS infection compared to control pigs actually increase pig days to market by about 2 weeks here. And then also if we just growth wean to finish kind of body weights over time, when a pig is given PRRS, we really get a attenuated growth response here, and then these pigs never really catch back up. So PRRS can be significant depending on the economic model. It's anywhere from $3 to $30 per grower pig is the economic cost of PRRS. So what does PRRS actually do to growth rates and feed intake? Really, we see that PRRS will decrease pig performance by 17 to 20%, and also this is combined with tissue accretion, and then leads to a leaner pig and also reduced market weight or market yields that slaughter in these pigs. So PRRS can be economically costly. One thing that we've seen with all of our different disease challenges, even our weaning research work, is the importance of feed intake. And the feed intake reductions seem to be a big factor describing a lot of the disease phenotype or stress phenotypes. So in order to test this, we have conducted research, and we are continuing to conduct research to try and work out the importance of reduced caloric intake or reduced feed intake. What is the contribution of that to the stress phenotypes that we see? And here's work that we've conducted with PRRS, where we had 3 treatments. We had pigs that were fed ad libitum that were non-challenged. We had pigs that were fed ad libitum that were just PRRS challenged. And then we had pigs that were feed restricted or restrict fed to the level of intake of the PRRS pigs, that these pigs were not inoculated with PRRS at all. And over a 35-day period, we wanted to see what was the contribution or the phenotypic responses driven by PRRS alone or caloric intake in these pigs. This top left figure here just shows that our PRRS pigs became viremic within 4 days, and then they slowly seroconverted over time. And our control pigs, whether it's pair-fed or restricted, ad-lib-fed pigs here, they remain PRRS naive. And again, we see the opposite with antibody response as expected. But here's our daily feed intakes that we see. So PRRS pigs, there's a significant reduction in feed intake within 3 days of viral infection compared to our ad-lib pigs. And it takes these pigs about 30 to 35 days to get their feed intake back up to the same level as their healthy, naive counterparts. And then our grey bar here, our pair-fed pigs, you see they've got identical feed intakes to our PRRS pigs by design. But what's interesting is that PRRS actually causes a sustained febrile response over time. So part of the PRRS phenotype is the pig has to maintain an elevated body temperature for at least 5 to 6 days compared to our ad-lib fed control pigs. And so this is the phenotype that we're dealing with. And so what happens, what's the contribution of feed intake reduction and PRRS to feed intake and average daily gain? Really, whether it's PRRS or feed intake reductions, they equal the same amount of actual average daily gain reductions over this period of time. So over a 35-day test period, we see that feed intake is explaining a lot of the PRRS phenotype, where we have up to about 60% reduction in average daily gain. And that's exactly the same if we just reduce the caloric intake over this period. And so this is the difference here. This is our ad-lib fed pig, our healthy pig at 35 days. Here's our PRRS pig, and here's our pair-fed pig. And you see just the difference in 35 days due to PRRS. And this is just due to feed intake reductions. So a lot of the things that we're seeing is that feed intake actually reduces actual growth performance in these pigs. And so how can we manage this PRRS phenotype? And here's some work that we tried to do. So we want to do 2 different strategies. One, can we manage the actual fever response? The febrile response has been reported due to PRRS using actual sodium salicylate in combination with vitamin B12 injections. And then that would be in our grey bar here. And then we also want to know, could we actually improve feed intake by giving the pigs a isotonic electrolyte solution? In this case, we use tonicity, and that will be called TON here. And as we go through a PRRS challenge here, this is days post-inoculation, where you can see that whether we use sodium salicylate or vitamin B12 injection or tonicity, we don't see any difference compared to our PRRS-infected pigs with regard to the febrile response over time. In other words, we could not mitigate the fever response due to nutritional or injectable interventions with these pigs, or water injected or needle injected if we're talking about B12 supplementation. We also thought that we could drive feed intake with tonicity, with an isotonic electrolyte solution in these 10, 15 kilogram pigs. And early on, we could drive a little bit of feed intake above the control pigs, but really at the end of the day, there was no difference in feed intake responses by these dietary intervention strategies. The one thing that we did see, whether we use an isotonic electrolyte solution or a combination of B12 sodium salicylate, is that we improve survivability of these pigs. And so we may not have a performance outcome, but we improve survivability, which is still very positive in the case of PRRS. And this also is translated to recent work that was published out of the University of Illinois, where Smith et al. Investigated the use of soybean isoflavones in the face of a PRRS disease challenge. And then these authors showed that over time, if we look at our blue line here, which is our positive PRRS-infected pigs, or their positive PRRS-infected pigs versus a non-challenged PRRS pig in black, is that PRRS reduces growth performance over time. However, there's very little differences with using isoflavones in these diets and actually improving growth performance of a pig over a 160-day period. But what these authors did show that the use of isoflavones, which have anti-inflammatory and antioxidative properties, they significantly reduced mortality or improved survivability of the pig. They also has been shown, this is work from Dr. Greiner back in the early 2000s, that their mode of action could be through actually decreasing the febrile response. So we don't see in the face of PRRS, there's a lot of opportunity to actually improve growth performance, but we are improving survivability using different nutritional strategies. And then this is a very good outcome, especially if we're talking about secondary or co-infections with pigs. And the last thing that we've been that I'm going to touch on is actually looking at the use of lysine to ME ratios in the diet to actually improve growth performance of PRRS-infected pigs. And I will say that of all the work that we've tried to improve growth performance of pigs, this has been the most reproducible and reliable for us in our hands, in our models. And so this was first reported by Wes Schwer back in 2018. So he reported that if we increase the lysine to energy ratios in the diet of grower pigs, whether they're at 25 or 50 kilograms, by about 110 to 120% of the requirement, which would be the control pigs, we can actually improve growth performance of these pigs using breakpoint analysis, and whether that was under natural or experimental infection. So then we went back in, and Jessica Jasper, a master's student who just finished up with me, actually conducted this work. She went in and actually validated this work in a more recent challenge model, the PRRS challenge model. And so what Jessica did in collaboration with the Mashovs, she wanted to increase lysine and amino acids by about 20% in the diet. She also wanted to dilute energy in the diet to achieve 120% ratio of lysine to energy. And then she tried to keep methionine, threonine, valine, trip, and isoleucine all the same as a ratio to lysine. So as lysine went up or down, everything else went up or down. And then she conducted this in about 400 pigs that were either PRRS vaccinated or non-vaccinated with the BI vaccine, and then all pigs then received the challenge. And I'll present this data both in challenge and in non-vaccinated and vaccinated pigs. And then these pigs also broke with PCV2 and strep during the challenge. So here's just our diets here. We tried to, our control pigs had a SID lysine to mCal of about 2.69 compared to 3.2. So that equated to around actually a 120% increase. And then we achieved the same ratio really just by diluting energy and keeping amino acids the same. And that's by using sand. And so in this challenge study that we did, this is the vaccinated and non-vaccinated. We all start off around 35 kilograms. We can see that in vaccinated pigs that were all challenged with PRRS, we had a significant improvement in end body weight and average daily gain and feed intake in these pigs compared to the control pigs when we just increased the lysine levels of the diet. If we dilute energy and have the same ratio, we also see a beneficial effect compared to, we got a 6 kilogram heavier pig over the test period. And this was partially driven by the response that when we dilute energy in the diet, we're actually driving a feed intake response. But this came at the cost of feed efficiency. We see something similar in non-vaccinated pigs. We see a 5 to 6 kilogram improvement in actual growth rates of these, in body weight of these pigs at the end of the 42-day period that equated to a significant improvement in growth rate, irrespective of how we achieved the 120% lysine. So in the face of a PRRS challenge, if we dilute ME or increase amino acids, these essential amino acids, to 120% of the lysine to energy requirement, we, under vaccinated or non-vaccinated situations with PRRS, we actually improve peak performance. And this validates what we saw and also reported with breakpoint analyses. So increasing dietary lysine to ME improves PRRS disease growth performance. It does not improve survivability or viremia outcomes, but overall we get an improvement in growth performance. Thus, depending on what strategy you use in the diet, you can have benefits for survivability or benefits for performance, but you may not necessarily have both. Jessica also reported that sick pigs will eat to their energy needs, as evident by pigs that were on a diluted energy diet. They ate more feed to meet their energy and nutrient needs. And then dietary amino acids to energy ratio may be more important than a single amino acid. In other words, it's probably a combination of all the amino acids and relative to energy that seems to be important, rather than just focusing on threonine or methionine or other sulfur amino acids. So in some general conclusions on this talk, that nutrient partitioning and metabolism priorities are altered during a pathogen and stress challenge, and that could be, we've been referring to weaning stress. When we're talking about growing pigs, nutrition can be used to attenuate these challenges. I could have done a whole talk just on intestinal integrity and function at weaning with different nutritional strategies, but I decided to keep it a bit more broad. The pathogens and different stresses negatively impact growth, and they also impact lean accretion, very similar to what they do with growth. Then the biggest thing that we're seeing from all of our stress models that we use, whether it's pathogen or weaning stress, is really the reduction in feed intake is the biggest antagonizing factor that's limiting peak performance during disease or stress. And so therefore I would challenge everyone to, we've got to find ways that we can get feed intake or drive feed intake using different nutritional strategies. And as I said, we can see improvements with survivability, whether we're using isoflavones as reported by Illinois, or whether we're using tonicity or isotonic electrolyte solutions in the water or gruel fed, or using sodium salicylate. These can have improvement in survivability, but they do not move the needle with regard to growth performance. And then at the end of the day, I think we all need to be clear with what our objectives are with using different nutritional strategies and products to actually improve growth performance of the pig. What will constitute success for us? And that is going to be different depending on the production system, the flow, whether we're a allied industry or a producer or a university. That's going to be different, and that's going to also dictate how we interpret the success of the study. And so to wrap it up, we've covered a lot of stuff, but I'd like to acknowledge current and past graduate students of my lab, Dr. Burrow and Patience and Schwartz from Iowa State for helping. A lot of this work was supported by the pork checkoff, the mash-offs, and also particularly from the USDA. And with that, just wrap things up. To keep on time, I'd like to thank you all for your attention, and I'll be happy to answer any questions. And we covered a lot of topics, so thank you.